Okay. So, based on Courtney's question last night, I put in some thought to this, and I think I figured out a way to determine which cases we see large differences between the raters. So we'll just do our first step here to identify what our agreement is. So just like last night, we're going to go to Analyze, we're going to go down to Scale, and we're going to conduct our reliability analysis. Click on that. I already have those in here. Let's pretend they're not. So we're going to put our raters in the items. We don't put anything down here. And then we're going to go to our statistics. And we want to make sure that it's going to show up like this when you first open it up. We want to make sure intraclass correlation is selected. We want to make sure we select the model for two-way random. And we want our type to be absolute agreement, because we're interested in the agreement between the raters. And this is already set at 95% for our confidence interval. That's all good. Test value would be our null hypothesis. Null hypothesis that there will be no agreement, so that value being 0 is perfect. And then this we can all leave alone. Continue. And we're going to press OK. And if we look here at single measures, since we're interested in the single raters, not average, because we're doing a two-way random, 0.877 is a pretty good agreement. It's a significant agreement. Our F value is 15, so we're capturing more of that significance from the agreement and less from error, which is good. And again, we can ignore this, but we have 100 cases in this. We have a lot of statistical power, but 0.877 is great. That's what we want. So say we're interested in, okay, well, we captured 87.7%, but there's still, around 23% error in our sample that we're not capturing. Let's see where that came from. So instead of scrolling all the way through this and looking for where the differences are between 100 cases, we could do something a little easier. We're going to do a transform, and we're going to do a compute. So that pulls up this. So again, transform compute, and we're going to just subtract rater 1 and rater 2. And what this is going to give us essentially is difference. What's the difference between rater 1 and rater 2 in each of these cases? And we're going to label this rater difference. So again, this is just giving us the difference between the raters. There's going to be negative and positive numbers. It doesn't really matter. We're just interested in differences. Click OK. So now we have our differences. So again, we don't have to scroll through here and see where the greatest differences lie. We can do a box plot. So we're going to go to Analyze, Descriptive, Statistics, and down to Explore. For Explore, we're going to put our rater difference in the dependent list. Then we're going to go to our statistics. Pull that over here. And we're going to click Outliers. So you want our outliers to present themselves to us. And we're going to click Plots. And pull that over. And we're going to click Histogram. Sometimes stem and leaf is already selected. We're going to unselect that. Select our histogram. This will give us normality. And we'll also do normality plots with tests to ensure that we can see our box plot and outliers and things like that. So click Continue. And we're going to click OK. So we have our mean. So this we can look at first, our descriptives. So our mean difference is 0.51. And if we look at our minimum and maximum difference, we have -10 and 13. So we have a 23-point swing here, but the mean is 0.51. So we have certainly some outliers that we have to be concerned about. Because if this was, say, 0 to 10, we'd expect our statistic for mean to be somewhere in between that, so around 5, which would tell us that everything's kind of merging around the center. We have an accurate mean, but for this, it's kind of lopsided. So that tells us we have outliers. So we can look here. This is our extreme values. So we have case number 64, case number 60, case number 58. This tells us what those extreme values are. But if we just look at our box plot, we could see those right here. So this is where our averages are, somewhere in this range. But these are our extreme cases. So let's test it out. Let's look at case 64 that identified. So that is a difference of 13. So that's a pretty great difference. Let's look at case 58. And we have, for 58, we have a difference of 11. For 60, difference of 12. For 53, a difference of -10. So this identifies where those differences are, what case, these are case numbers, these aren't the actual values. So when you look at the cases, they tell you what those values are. So just answering to that question of how do we assess differences when we have decent agreement, or say our agreement's low, we really want to see what questions our raters are struggling on. This is how we figure it out. We can go back, we can assess what question this was, where the confusion may be, and it may be time to adjust the code book accordingly. So that's it. Thanks, Courtney, for the question.